Hello everyone, I Vikas Nehra welcome you all to session number 53 of our ongoing RHCSA version 10 training. In this session, we will talk about kernel modules management, and kernel parameter tuning in RHEL 10. We will also cover some other topics like what are libraries in Linux, how can we inspect and manage the boot parameters, and at the end I'll give you the practice exercise as well. Before I start the session, we must know what are kernel modules and why do we use them. So the question is, what are kernel modules? Kernel modules are object files having the extension as .ko that extend the functionality of the kernel at runtime. For example, device drivers like NIC cards, USB, file systems, system calls. So these all are kernel modules in Linux. Why do we use them? Kernel modules are used to uh, introduce certain features, to tune the functionality of the kernel, and you don't need to reboot the system to add the functionality. Suppose we want to add certain features in our OS, so we don't need to reboot the system or to install a package. If the module is available for that functionality, we can directly load the module in the kernel to add the functionality. Because of modular design, it improves the stability and scalability of the Linux OS as well. So kernel modules are used to add the functionality in the system without even rebooting the machine, and they offer modular design which improves stability and scalability. Now I will talk about working with kernel modules. How can we check the loaded modules in our machine? There is a command which we can use, and the name of the command is lsmod. If you want, you can just read the manual of this command. It shows the status of modules in the Linux kernel. So lsmod is the command which we use to check the loaded modules. What are the modules which are currently loaded in the kernel? And each module offers a feature or the functionality. So these are the modules which are showing up here in the output, which are currently loaded in the Linux kernel. If you want to count these modules, you can just use filter here and you can mention wc-l. So there are total 78 modules which are currently loaded in the Linux kernel of our machine. If you want to search a specific module and if you want to know whether it is loaded or not, you can just grab it in the output of lsmod. Suppose I want to check whether the XFS module is loaded in the Linux kernel or not, I can execute this command. So XFS kernel module is currently loaded. So the output of lsmod shows us that there are 3 columns. The first column is for the module name. The first column represents the name of the kernel module like XFS, CD-ROM, HCI, These are like drivers that extend the kernel functionality. The second column, it shows the size of the module in byte. It is not the memory uses in RAM, but the module file size in the memory. So this second column, it tells the size of the module in bytes. And the last column, this one, third column, it tells the number of references to this module. That is, how many other modules and components are using this module. If this value is 0, that means this module is loaded but not actively used. So you can have a look at this. This 0 represents the module is loaded, but it is not currently in use by the other modules or the components. For AHCI, this one, we have this value as 1, which means this module is used by some other module or the OS component. Only one other component or module is actually using it. If this value is 2, that means there are 2 modules or components which are using it. Okay. Similarly, in case of this XFS module, we can see that the module name is XFS. The size of this module is 32071168 bytes. So this module is about 3.2 MB of kernel memory. So this module is using about 3.2 MB of the kernel memory. And the last column, this one, it is showing the number of active references to this module. Typically reflects how many XFS file systems are currently mounted or how many other kernel modules are using it. Now, how can we load a module? Some modules are by default loaded when machine starts up. Some modules we can manually load to add the functionality in the Linux kernel. To load the module, either we can execute the modprobe command or we can use the insmod command. There are 2 methods of loading the kernel modules, either by using the modprobe command and mentioning the module name, or by using the insmod command and mentioning the exact path of the module file. Okay. So what are the differences between the modprobe command and the insmod command? Actually, the modprobe command, it handles the dependencies, while the insmod command does not handle the dependencies. Dependencies means there are certain modules which are dependent on the other modules. So you need to install the dependent modules first in the kernel memory. After that, you can load this module. So modprobe command can automatically load those dependent modules first, while the insmod command won't do that. Second point, modprobe command doesn't need the complete path of the module file. So module location awareness is there in case of the modprobe command. System knows from where to load this module. In case of insmod command, we need to mention the full path of the module like this. Third point is ease of use. Modprobe command ease of use is high, while the ease of use for the insmod command is low because it requires manual control. If you want to unload the module, you can use modprobe-r flag. In case of insmod, if you want to unload the module, you can execute rmmod command. So let's cover these commands in detail. Let me show you. Suppose I want to check whether the IP tables module is currently loaded in the kernel memory or not. So I can simply grab IP tables in the output of ls mode. So there is no such module currently loaded in the Linux kernel. IP tables we use for packet filtering in firewall. So it is a kernel functionality. So if we want to use IP tables, we need to load this module in the kernel memory. So how can we load this module? We can execute the modprobe command. Modprobe and the module name, that is IP_table. So the module is loaded by running the modprobe command. But how can we confirm? We can re-execute the lsmod command and we can grab IP tables there. So this module is now loaded in the kernel memory. How can we remove this? Either we can use modprobe -r command, or we can execute rmmod command. After rmmod, we can mention the module name, that is IP_tables. This will unload or remove the module from the kernel. I have shown you how can you load the module by running the modprobe command. Now let me show you how can we load the module by using the insmod command. If you use the insmod command and mention the module name, it will not work because it requires the complete path of the module file. So we have to check from where to load this module. Insmod command doesn't have the module location awareness. How can we check the exact path? So there is a method. We can execute mod_info command, and after that we can mention the module name. Mod_info command provides the detailed information about any kernel module. Here you can see that this command not only shows the file name, but the exact path of the module file as well, description, who is the author, license, RHEL version, source version, whether this module is dependent on some other modules or not, entry, name. So there are a lot of things which are available with the mod_info command. Here you can see that we have the complete path of the file, which we can use to load the module by running the insmod command. So we can copy it from mod_info and we can execute insmod command, and after that we can simply mention the exact path of the module file for the IP tables module. Wait a minute, let me check the version of my machine. 6.12. Let me reset this machine back to the previous state, because the kernel version is different. So I'm going to use the same machine which I used in the previous session where we compiled the latest Linux kernel. So I just restored my machine and let me show you the kernel release. Now it is showing the latest kernel release, that is 6.15.8. So let me show you. If I execute the insmod command to load the module, that is IP_tables, it will not load. So what we will do, we will execute the mod_info command, and after that we will mention the name of the module, So the command will show us the module file name, which we can copy, and after that we can use it along with the insmod command. Insmod and the module file name. So this will load the module in Linux kernel. Now let's verify whether the module is loaded or not. So let's execute the lsmod command and let's grab IP tables here. So the module is successfully loaded in the kernel memory by using the insmod command. Okay, now I will explain how can we unload the module. To unload the module, either we can use the modprobe-r command or we can use the rmmod command. Let me unload the module. So let me execute the modprobe-r command with IP underscore tables to unload this module from the kernel, and let's verify it in the output of lsmod. So you can see that the module is successfully unloaded. Now let me reload the module back. You can see that module is again loaded. Now let me unload it by using the rmmod command. After rmmod, we can simply mention the module name. We don't need to mention the exact path of the module file because this module is already loaded there. Now let's verify whether the module is unloaded or not. So you can see that the module is successfully unloaded or removed from the kernel. So to unload the module, either we can use modprobe-r command with module name, or we can use rmmod command with the module name. To see the information about the module, we can mention module name after mod info. So to check the detailed information about this module, we can simply write there mod info and the module name, which is IP underscore tables. So this is the detailed information about this module. Now we will talk about module dependencies. What are module dependencies? Module dependencies are other kernel modules that a given module relies on to function correctly. Just like software libraries depend on the other libraries, a kernel module might require other modules or dependencies to be loaded first. Like we see in the package management, where if we want to install a package, it requires some other package installation first. Suppose we want to install a game which requires DirectX installation. So we need to install DirectX first, and after that we need to install the game so that we can play it. So same in case of the modules. Some modules are dependent on the other modules. So you need to resolve the dependencies first. What are dependencies? Let me show you. Look at this. We call it dependency chain. So this nf contract FTP module is dependent on nf contract, and this nf underscore contract module is dependent on nf defrag IPv6 nf defrag IPv4. So we need to install these modules first. After that we need to install this module, and then we can install this module. So if we want to use a module which is dependent on the other modules, so we have to resolve the dependencies and we need to install the dependent modules first in the kernel memory. So what we have to do? We have to install the dependent modules first. Let me show you. Let me see the detailed information about the first module which we want to load in the kernel memory. So if you check there, you will see that it will show you here depends. So this module which we want to install or load, this one nf underscore contract underscore FTP, it depends on some other module, that is nf underscore con track. If you see the information about this dependent module, it further shows some dependencies on these modules, which I shown you in the dependency tree in the previous image. So this module is again dependent on these two modules. So we need to install these two modules first. But before that, let me show you whether these modules are dependent on some other modules or not. So this module is not dependent on the other module. Same in case of the other one. It also shows that it is not dependent on the other modules. So if we want to install a module which is dependent on some other modules, we need to resolve the dependencies and we need to install the dependent modules first. So if we use the insmod command, that will create a lot of problems because we need to resolve the dependencies manually and we need the complete path of the module file as well. Suppose I want to check whether the module is loaded in the memory or not. So this module is currently not loaded. In case if we want to load it, we should use the modprobe command because here we don't need to resolve the dependencies and we don't need to mention the path of the module file. And let's verify whether the module is loaded or not. So module is loaded there. This module is used for FTP connection tracking in NetFilter. So this is a functionality which we want to add in the Linux kernel, whether we want to use it for the FTP connection tracking in NetFilter, we can load this module in the Linux kernel. If we want to unload it, we can simply mention modprobe-r and the module name. You can see that module is successfully unloaded. In case if we want to load it using insmod command, so we cannot directly load it. We need to load the dependencies first, and we cannot directly load the dependencies. We need to use the complete path of the module file. So we need the complete path of all the dependent modules and we need to resolve the dependencies manually. So that's why we prefer the modprobe command in place of the insmod. Now the question is, where are dependencies stored? After installation, dependencies are mapped in the modules.dep file. So we have a file there in the /lib modules directory. In the last session when we were compiling the Linux kernel at that time, you might have seen that a lot of files were getting generated there in the /lib/modules directory. So in that location, we have a directory which is having the same kernel release. There we have this modules.dep file. In place of this, we can write 6.15.8. So either we can mention the kernel release or we can mention there uname-r. Uname-r is obviously easy because we do not prefer to remember the numbers. So this is the file which is responsible for the dependencies. If you will check the contents of the modules.dep file, you will find that all the dependencies are mapped there. Which kernel is dependent on which one, everything is there. So from this file, the machine knows about the dependencies. This file is created by the depmod command, which scans all .ko files to find who depends on what. You can just read the manual of dep mode. Dep mode generates modules.dep and map files. So this file is actually responsible for knowing about the dependencies. If you want to load, or if you are adding or changing the modules, you should always run dep mode -a. It will update the dependencies there in the file. So if you are adding or changing the modules, you should execute this command. You can set the aliases for auto loading. There is a file for that as well with the name as modules.aliases. If you want, you can check this file. So if you want to give another name to the module, you can make an entry here in this file. This file is used for aliases for auto loading. There is a directory under /etc with the name as modprobe-d. It contains the configurations for the module options and behaviors. Okay. Modprobe and insmod command, modprobe or insmod command doesn't load the kernel modules permanently. It loads them temporarily, meaning the module will not persist after a reboot by default. So how can we make module loading persistent, which can survive system reboot? So you need to configure your system to load the module at the time of booting, and there are two ways of doing that. There is a file under etc directory with the name as modules. If this file is not present, you can create it. How? Let me show you. Suppose I want to make IP_tables module permanent, which should be permanently loaded in the Linux kernel memory. So I can make an entry in the etc modules file by using this command. Either we can use the VI editor for this, or we can simply use the echo command to make an entry in the etc modules file. Wait a minute, let me show you. We can execute the command like this. Or we can use the VI editor. And simply we can mention here the module name. So we can make an entry in the etc modules file. This will automatically load the module at the time of booting. Or what we can do, we can create a config file in the etc modules.d directory. The location is /etc/modules-load.d, and here we can create a file with the extension as .conf. or we can use the VI editor as well. Simply mention the name of the file after VIM, and here we can write IP underscore tables. Let me show you the entry which I just made here, IP tables. Actually, I mentioned has there, which should not be present after the filter. So if you are doing it with the help of the echo command, you can simply execute the command like this. Okay. So either make an entry using the echo command and filter, or use the VI editor. So there are two methods of loading the modules permanently. The first method is to make an entry in the etc modules file, and the second method is to create a config file in the /etc/modules-load.d directory and make an entry there in that file. Okay. Now I will talk about the security and best practices about the kernel modules. Only load signed or trusted modules. We should never load the untrusted or the unsigned modules in the Linux kernel. If you want to prevent auto loading, you can blacklist the module as well. How? Let me show you. Suppose I want to blacklist the IP underscore tables module. I want that it should not be loaded there in the Linux kernel. How can I prevent the module from getting loaded there? We can simply make an entry in the /etc/modprob.d directory, and there we can create a file with the name as blacklist.conf. So we can make an entry there in this file for the module. Right here, blacklist and the module name. The location of the file is /etc/modprob.d. So in this directory, we can create a file, and there we can make an entry. We can write their blacklist and the module name. Now, to enable this file, we can simply mention one there in modules underscore disabled file. So this file is present in the proc directory under sys under kernel. This file is getting updated from the Linux kernel directory and directly. So if we write there one in this file, what will happen? It will reload the configuration from the files which are present in the /etc/modprob.d directory. So the contents of the blacklist.conf file will be loaded there in the Linux machine. So the kernel understands which module to block, which functionality to add. So since we mentioned their blacklist, that means IP tables module will be blacklisted. Now, if we want to check whether we can load the module or not, we can execute the mod probe command. So this will throw an error, operation not permitted. Since this module is the blacklisted module, kernel already knows about this module. This module is already blacklisted. So that's why the module is not allowed to be loaded in the kernel memory. Okay. Now we will talk about libraries. In Linux, libraries are collection of pre-compiled code that application or other program can use. They provide shared functionality to avoid code duplication and to standardize common tasks. There are certain commands which requires libraries. As I have shown you in the previous sessions, if I talk about the binary files which are there in this /usr/lib, these are the binary files for the commands. These commands will only execute if we have the libraries there. So if I show you the contents of the root file system, we do have some directories with lib and lib64 names. These directories contain the libraries which are required by the binary files of the commands. So if I show you the contents of /usr/lib, you can see that we have the libraries there. So libraries are the collection of the precompiled codes that application or the other programs can use. There are two types of libraries in Linux. Static libraries, which are having the extension as .a, and the shared libraries. We call them dynamic libraries also. These libraries have the extension as .so. Static libraries, which have the extension as .a, they linked into programs at compile time. Code becomes the part of the executable. No need for the library at runtime. If I talk about the shared or the dynamic libraries which have the extension as .so, they linked at runtime. Multiple programs can share the same library in the memory. They are generally saved in /lib/usr/lib, and the examples are lib.so or libm.so. I'll show you how can we check the libraries. If you want to list the libraries related to any command, you can use the ldd command. Suppose I want to check the libraries related to the ls command. So I can write there /bin/ls. It will show all the libraries. These libraries are having the extension as .so. That means these are the shared libraries. Okay. Similarly, we can check for some other commands like mkdir. Cd is not a dynamically executable file, so that's why no library is showing up here. So these will be available for the external commands. So all these are the libraries which are related to the binary files. Now we will talk about the kernel parameter tuning. Linux kernel parameters are settings that control the behavior of the Linux kernel at boot time or during the runtime. We can always control the Linux kernel behavior. This is a flexibility which is only available in the Linux operating system, not in other operating systems like Windows. In Linux, we can control everything. We can control the behavior of the Linux kernel, not only at the runtime, but at the booting time as well. So there are parameters which we can use to control the behavior of the Linux kernel. Kernel parameters can configure hardware, enable or disable the features, optimize the performance, improve the security, debug the issues, fix the bugs. So all those things are available with the kernel parameters. So we can tune the kernel parameters accordingly. Why kernel parameters are used? They are used in the hardware configuration. How? specific things like interrupt requests, memory limits, device drivers, we can specify those things. Suppose I want that the system should use only 2 GB of RAM. So I can limit that. So we can specify the things like interrupt request, memory limits, device drivers, etc. Second is the boot behavior. We can modify how the kernel starts or how it treats the certain subsystems. For example, suppose I want that the machine should start in the rescue mode. So at the time of booting, I can select the kernel parameter line. There I can press E, and after that I can go in the kernel parameter line and I can define that I want to start this machine in the rescue mode. So we can always control the boot behavior. Third is performance tuning. We can adjust the scheduler, memory management, networking, etc. We can enhance the security. We can enable or disable the certain features. Suppose I want to disable SE Linux. I can easily do that. I can disable the firewall. I can easily do that. We can debug and troubleshoot the issues. We can directly start the machine using the bash shell by mentioning init is equal to /bin/val/bash at the time of booting. I can define it in the kernel parameter line. Now the question is where kernel parameters are used. Kernel parameters are used at booting. कहाँ पे यूज होते हैं? Where do we use them? /etc/grub /etc/default/grub. If we want to change the kernel behavior at the runtime, we can do it by using the sysctl command. So where kernel parameters are used? They are used in booting, at the boot time, and at the runtime as well. And on both places, we can define the kernel parameters to modify the kernel behavior. Suppose I want to change the grub timeout. So I can do that with the help of /etc/default/grub file. I can open it in VI editor and I can define the grub timeout settings. Suppose I want to make it 15 seconds, I can write there 15. Here, suppose I want to start the machine always in the single user mode. So I can define that here in the grub cmd_linux line. This line is responsible for the kernel parameters. By default, you can see that it is showing the path of the root file system, swap, and RHGB quite is also mentioned there. So we can change the parameters here in this file to make changes in the kernel parameters at the time of booting. And then we can just execute the update grub command so that these changes can apply. If we want to change the kernel parameters during runtime, we can use sysctl command. Sysctl-a we can use to list all parameters. These are the parameters which are currently defined. And these parameters can change the behavior of the Linux kernel during runtime. Suppose I want to list the specific parameter, like I want to look for this one, net.ipv4.ip forward. So I can mention the parameter name after sysctl and it will show the value of this parameter. Suppose I want to change the parameter value temporarily. So I can mention sysctl, parameter name and the value. Earlier it was 0, now I want to make it 1. So I can mention 1 there. After that we can verify the parameter value. Earlier it was 0, now it is showing here as 1. So what is this parameter used for? Net underscore net.ipv4.ip underscore forward. This parameter is a Linux kernel setting that controls whether your system can forward IPv4 packets or not. In other words, I can say that whether your machine can work as a router for the IPv4 traffic or not. So with the help of this kernel parameter, we can change the behavior of our machine, whether we want to use the machine as a router for the IPv4 traffic or not. If we want our machine to behave like a IPv4 router to forward the packets, we can simply make this value as 1. Or if we want to just disable it, we can keep it 0. When IP underscore forward kernel parameter value is 0, that means IP forwarding is disabled. And when this value is 1, that means IP forwarding is enabled. So it is just a value of the kernel parameter which can completely change and modify the behavior of our machine, whether we want to use the machine as a router for the IPv4 traffic or not. So that we can control with the help of this kernel parameter value. These changes are temporary. So if I change the value of the kernel parameter, it is temporary. It cannot withstand system reboot. So if we want to make it permanent, we can simply make an entry there in the sysctl.conf file. How can we do that? Let me show you. Let me show you the value of this kernel parameter, which is showing here as 1. And suppose I want to check the value of the vm.swappiness parameter as well. So it is showing the value as 60. You are already aware of this parameter. I have already used it in the swap management section. That's why I'm taking the example of the same kernel parameter here. Suppose we want to define these parameters and we want to make them permanent. So what can we do? We can simply create a file there in the /etc/sysctl.d directory, and we can mention any name for the file, but the extension should be .conf. Here we can define the parameters. So I'm enabling the IP forwarding parameter and I'm mentioning the swappiness parameter value as 10. So we have just made the entry there in the file. To apply the changes, we can execute sysctl --system command. This will load the entries from the file, and let's again verify the parameter values. So IP forwarding is enabled. Now let's check the vm.swappiness parameter value. Earlier it was 60. Now it should be 10. Because this time this value has been replaced from the entry available in the file. Now, even if we reboot the machine, these parameters will remain the same because our machine will load the values from the file that we created there in the /etc/sysctl.d directory. Okay, now let's proceed further. Now we will talk about inspecting the Linux kernel and boot parameters in RHEL 10. If we want to check the running kernel version, we can execute uname-r command. It shows the kernel release. Okay. If we want to see the kernel boot parameters, we want to check what are the parameters with which the machine can boot. So we can simply open the proc cmd line file. You know that all the files which are available in the proc directory are directly getting updated from the kernel itself. So this file actually holds the boot parameters. You can see that. What is the location of the boot image? Hard disk 0, which is using the GUID partition table 2. There it will load the kernel image, which is having the name as VM Linux 6.15.8. What will be the root directory or the root file system? That is /dev/mapper RHEL-root. Read only kernel crash. We will talk about it in the kdump section. UUID is there. So all the parameters which are used at the time of booting are available in this file. If we want to modify kernel parameters at boot, suppose we want to boot the machine in single user mode, or suppose we want to reset the root password, suppose we want to add or remove the password at grub. So how can we do that? To modify kernel boot parameters, like in case of root password reset or in case of some troubleshooting, we can reboot the machine. At the grub menu, we can select the kernel. There we can press E, and after that we can modify the kernel line. How? Let me show you. Simply reboot the machine. Then we will move on the virtual machine console. There we will wait for the machine to start again. Now machine is starting up again, and here we will see the boot menu. There on the grub menu, we'll select the kernel. So the first line is the available kernel. Here we will press E. It will show us these lines. Here we will go in the kernel line, and there we can define the kernel parameter. Suppose I want to reset the root password. I can write here rd.break. Or suppose I want to directly access the bash shell. I can write here init is equal to /bin/bash. This method we were using on RHEL 6 and 7. And here we can press Ctrl and X. This will immediately start the machine with parameters that we have defined here in the kernel line. Look, we will directly get the shell access. These things we will use in the upcoming sessions. Look at this. We have got the access on the bash shell. So this is how we can use it. Now let me restore my machine back. Let me restore it from the previous snapshot. That was snapshot 5. Now we will talk about viewing kernel boot messages. Let me check the IP address. Okay, we are back. Now I will explain how can we view the kernel boot messages. We can see the kernel logs. Kernel logs are stored in the var log messages directory, messages file. So we can simply open this file. It's better to use the more or less command to read the contents. So we can simply go through the kernel logs with the help of this file. Okay, we will cover it in detail in the logs management section. If we want to read the kernel ring buffer means boot plus runtime logs. So we can execute the dmessage command. What is dmessage? It prints or control the kernel ring buffer. So we can execute the dmessage command. It shows the kernel ring buffer messages. And here we can grep certain string which we want to see. Suppose I want to see the information about NVMe disk. I can write there NVMe. So it will print all the events related to NVMe. Okay. Now we will talk about kernel source code and downloads. Linux kernel source code. All of you are aware of the location that I've shown you in the previous session. www.kernel.org is the place where the Linux kernel source code is present from 1991 onwards. So if we want to see, we can open the internet browser and there we can mention www.kernel.org. We can visit this page. It contains all the kernel releases from 1991 onwards. Okay. Now the question is whether we can have the local kernel source directory or not. Actually, the kernel source code might be locally available in the USR SRC directory. If you visit there and list the contents, you will see that there is a directory present with the name as kernels. This directory is responsible for the local kernel source. Red Hat is a community based Linux. So generally we don't see the Linux kernel source code here. But if we want, we can have it. How can you see it? You can install kernel development headers. You can manually install some packages to see the kernel source code. If you are building kernel modules, you don't need the full kernel source. You can directly install the headers by running the yum install command. Yum install kernel devel kernel. Actually, my repository is mounted on the mnt directory. So let me mount it back so that my repository can work. Now, if I execute the yum install command, I can install these two packages, kernel-devel or kernel-headers. Once these packages are installed, we can verify them. We can verify the installation. So we'll simply see the contents of the /usr/src/kernels directory. There we will see another directory with the kernel release name, and inside that directory we can see the kernel source code, Linux kernel source code. Kernel-devels package takes some time while installing, so we have to wait here for few seconds. All of us are aware that Linux is the open source operating system, so we can easily modify, we can always see and modify the source code to enhance the features, to add some functionality there in the Linux machine or Linux operating system. So if I talk about the local source directory, that is /usr/src. If I visit the /usr/src directory and list the contents there, kernels directory is there. We can move under this directory and we can list the contents. Now we have one more directory here which is showing the kernel release name, that is 6.12.0, this one. And why we have this directory here? Since we are installing kernel devel packages, so whenever we install kernel devel and kernel header packages, they will automatically create a directory in this location. Now we can move under this directory and we can list the files there. So this is the kernel source code. This is the Linux source code. It is similar that I have shown you in the previous session. We installed and we compiled the Linux kernel by using the kernel tarball. So we have downloaded the Linux kernel source code with the help of the zip file. We unzipped it, and there, after unzipping it, we can see it, and we compile it in the previous session. So similarly, we can see it there in the kernels directory, which is present in the /usr/src, and there we can see it. This is the source code of the Red Hat Linux kernel. Okay. Now we will talk about understanding the Linux kernel RPM packages. In RHEL Linux, the Linux kernel is modularized and distributed via multiple RPM packages. This structure helps system admins to optimize performance, reduce surface attack, and minimize disk usage, especially in virtualized and the cloud-based environments. The kernel package itself is a meta package. Meta package means empty placeholder. Meta package means empty placeholder that pulls in the required sub packages. So if I check the kernel package, suppose I want to check the information about the kernel package in the available repository. So I can execute dnf info kernel command. This command shows us the detailed information about kernel. Name is kernel, version is 6.12. This kernel is actually present in the ISO image. This is the release, this is the architecture, this is the size, this is the source RPM, this is the repository where this is actually available. So it is not a single package. You will see that it has no actual files. There are no certain files. If you execute the same command for some other package, like suppose I want to check for LVM2. So it shows us the detailed information about it, the package, file name, everything. So in case of kernel, you will see that it has no actual files, but it actually depends on some other files. So the kernel is actually dependent on three sub packages. The first is kernel-core. It contains binary kernel image, initram fs related tools, and minimal set. The second one, kernel-modules. It contains the remaining kernel modules which are not present in the kernel core package. It includes common drivers and kernel features. So Linux kernel is not available in form of a single RPM file. It is actually available in form of multiple sub packages like kernel core, kernel modules, kernel debug, kernel tools, kernel devel. So if you want to install the Linux kernel, you need to install minimum two packages, kernel core and kernel modules. If there are some dependencies, they will be automatically resolved. Okay, one more thing which I would like to tell you. In the previous session, I have shown you that the boot directory contains the rescue kernel image, VM Linux rescue, initram fs rescue, from where we get these files. So these files are available because of kernel-debug package. These files are actually present because of kernel-debug package. If you install the kernel debug package, you will see that these files will be generated automatically. Okay. Now, I'm going to give you some practice questions. You guys are requested to perform them in your respective machines. The first question is you need to load and inspect a module. Solutions are also given over there. And the second question, you need to temporarily change a kernel parameter. In the third one, you need to make the parameter persistent. After that, you need to block a module from loading. In the fifth question, you need to automatically load the module on the boot time. Sixth question is very interesting. You need to create a custom kernel module. I've given the solution. You can check it. You can try it at your own. So first you will install the development tools in your machine. After that, you need to install kernel devel and kernel header packages. Then you need to make sure that your kernel devel matches the current kernel version. So you can execute uname-r command and rpm-q command for kernel devel. Both commands should show you the same kernel release. If they do not match, you need to reboot on the correct kernel. Means your kernel devel release should match the current kernel version. After that, you can create the module source file. Then you need to create the make file. Okay, let me show you how we can do it. So let me restore my machine from the snapshot, because what is the problem here in this machine? Since we have compiled the latest Linux kernel, so the output of uname-r will not match with the kernel version of kernel-devel package. Here you can see that kernel devel version is 6.12.0 while the current kernel version is 6.15.8. So either we can reboot the machine, we can start it up again with the other kernel, or I can simply restore it from the snapshot. Let me show you how can we do it. Either I can reboot it from that kernel, or I can simply use this snapshot to restore my machine back. Our machine is back. Now let me again verify the current kernel version, current kernel release 6.12.0, and let's verify the kernel devel version. Kernel devel is not installed, so let's install it quickly. DNF. First we will install the development tools. I mentioned in the previous session that there are total 128 packages which are used in the development. If we want to compile the kernel, or if we want to make some package, or if we want to create the kernel module, we need to install the development tools packages. So there is a collection of the packages with the name as development tools. Let me show you the collection. How can we check what are the group of packages available? DNF group list all is the command. This command shows the collections. These are the collections or the groups of packages. Suppose we want to use GUI. Suppose we made the installation in the minimal mode, but later on we need the GUI. So we can directly install those packages which are required, but we do not know how many such packages are required for the GUI. So we can directly install those packages from this group. So we can use this option of the group name server with GUI. Similarly, if we want to perform some development task, we can install development tools packages. So there is a collection of packages which are required in the development. So this group name is development tools. So we don't need to select the packages manually. We don't need to install them manually one by one. We can directly execute DNF group install command, and we can mention the group name. So those packages will be automatically installed. So what we will do, we will again verify the current kernel release and kernel devel package release, but kernel devel package is not currently installed, so we need to install it first. So after installing the development tools, we can install kernel devel and kernel header packages. So these are automatically installed because I think they are a part of the development tool collection. Now let's verify whether uname-r command and rpm-q kernel-devel shows the same release. Now You can see that current kernel release and the kernel devel release both are same. After that, we can create the module file. And module files can be written in C. If you are familiar with C language, you can easily understand why we are using this code. So this is a simple program which is written in C. It will print goodbye kernel, hello kernel. So we are using it, and here you can modify certain things. Suppose you want to mention the module license name. I can write here Nehra classes, module author. Let's mention here the name as Vikas Nehra. Okay. After that, we need to create the make file. Make file is nothing but having the instructions how to compile the program. So we'll simply mention the instructions here in this file. The object name hello, the path. Okay. After that, we can compile and load the module. So we can compile it by running the make command. We have successfully compiled the program. Now, if I execute the ls command, I can see that hello.ko file is created there. This is the module file. So we can use this file to load the module. Let me execute the insmod command, and after that I can mention the module file name. This will load the module in the memory. Now let's verify whether the module is loaded or not. Look, module is loaded there. Now let's check the kernel log output. So let me execute the d message command, and let's see last 10 lines. Look, module license Nehra classes, module verification failed because it is not the official module. Hello kernel. Now let's remove the module. How can we remove it? rm mode command we can use, and then we can mention the module name. This will unload the module. Now verify whether the module is unloaded or not. And after that, we will again check the logs. Look, once the module is unloaded, it is saying goodbye kernel. When we load it, it print the message as hello kernel. Now we are able to see the goodbye message for the kernel. Okay. If you want to see the detailed information about the module, simply mention the mod info command there on the terminal and the module name. This is the file name. Description, simple hello word module. Author is Vikas Nehra, license to Nehra classes, RHEL 10 version. It is not dependent on the other modules. The module name is hello. Okay, so this is how we can see the detailed information about the module. So that's it from my side. You guys are requested to perform the practice exercise. If you have any questions, you can ask me now. Hello. Any questions?
It was a very big session, sir. Well, thank you for the session. I mean, थोड़ा practice करना पड़ेगा सर.
बिना प्रैक्टिस के नहीं हो पाएगा.
Yeah.
लेकिन ईजी है बहुत, मतलब कुछ ऐसा नहीं है जो मुश्किल वाली चीज़. अगर आपने स्टार्टिंग में अच्छे से पढ़ा है then you will not face any challenges.
मोस्टली मॉड्यूल्स पूरे जब आप कर्नल के साथ आते हैं ये सर मैक्सिमम, और जो जो नए हैं कुछ उसको आपको बस डाउनलोड करना पड़ेगा।
नहीं, बना भी सकते हैं, जैसे मैंने बना के दिखाया, आपको
तो अभी
प्रोग्राम
हाँ
लिखना
आपने
आना
अपने
चाहिए।
बनाया जी।
इसीलिए लिनक्स ऐसा ऑपरेटिंग सिस्टम है जिसमें आप कुछ भी कर सकते हैं। आपको सी का प्रोग्राम लिखना आता है, आप मॉड्यूल बना सकते हैं। आपको पता होना चाहिए कि मॉड्यूल से क्या काम आप करवाना चाह रहे हैं।
क्या बात है।
लेकिन बहुत सारे मॉड्यूल्स ऐसे हैं जो कंपाइलेशन के टाइम पे आपको मिल जाएंगे कर्नल के साथ भी। ठीक है।
ये जो और एक जो नई चीज आई सर मार्केट में, जो EBPF, इज इट वेरी सिमिलर टू मॉड्यूल्स?
क्या चीज़, क्या बता रहे हो?
EBPF।
फुल फॉर्म बताओगे एक बार क्या है?
मैं आपको एक सेकंड,
ये चैट में डाल दो।
मैं
मैंने यहाँ
दादाजी।
गलती से जो है ना ये लगा दिया था, हैश। इसको हटा देता हूँ मैं। एक्सटेंडेड बार्कले पैकेट फिल्टर पैक, ये तो पैकेट फिल्टरिंग के लिए है। मॉड्यूल अलग चीज़ है। पैकेट फिल्टरिंग जो है ये एक फीचर है जिसे, मतलब ऑब्वियसली मॉड्यूल पे डिपेंड कर रहा होगा। कर्नल का फीचर है ये। पैकेट फिल्टरिंग से मतलब ये है कि आप सर्टेन पैकेट्स को अगर रोकना चाहते हैं तो आप कर सकते हैं, जैसा कि हम फायरवॉल के केस में करते हैं। फायरवॉल क्या काम करता है? फायरवॉल में भी बैकएंड पे नेट फिल्टर नाम का मॉड्यूल यूज़ हो रहा होता है। अगर मैं मशीन पे दिखाऊं आपको, तो यहाँ आपको देखिए दिखने
हाँ,
ग्रैप नेट फिल्टर करके होता है।
NFT वही होता है ना सर, नेट फिल्टर?
नेट फिल्टर, तो नेट फिल्टर जो मॉड्यूल है वो बैकएंड पे पैकेट फिल्टरिंग का काम करता है। तो ये EBPF जो है, एक्सटेंडेड बार्कले पैकेट फिल्टर, ये जो है मेरे ख्याल से मॉड्यूल ही होना चाहिए। हाँ, पैकेट फिल्टरिंग के लिए इसको यूज़ करते हैं। ये कर्नल टेक्नोलॉजी है और इसकी मदद से जो है सैंडब्रो, इट इनेबल्स द एग्जीक्यूशन ऑफ सैंडबॉक्स्ड प्रोग्राम विद इन द कर्नल स्पेस। हाँ, बिल्कुल मॉड्यूल की तरह ही काम कर रहा है। मॉड्यूल ही होगा ये, इनफैक्ट जो है ये फीचर किसी
ये
मॉड्यूल पे डिपेंड कर रहा होगा।
हाँ, ये इसी में मतलब क्यूबरनेटीज में नई चीज आई हुई है सर, ये जैसा कि ऑब्वियसली वो आईपी टेबल रूल्स वगैरह वही सब क्रिएट करता है ना, तो उसको
इज ए
देखने करने के
फीचर
लिए थोड़ा।
लिनक्स कर्नल दैट इज नॉट सेपरेट कर्नल मॉड्यूल। अच्छा, ये इनबिल्ट इन्होंने हार्ड कोड कर दिया है इसको।
हम्म,
इट इज़ नॉट अ सेपरेट कर्नल मॉड्यूल विद अ डिस्टिंक्ट नेम। ये इंटीग्रेट कर दिया इसको इन्होंने। मतलब बेसिकली क्या है, अभी तक हमारे पास ऑप्शन हुआ करता था कि वेदर वी वांट टू इनेबल द मॉड्यूल और नॉट। अगर इनेबल करना है तो लोड कर दिया, इनेबल नहीं करना है तो लोड नहीं किया। इन्होंने इसको हार्ड कोड कर दिया है इसके साथ। मतलब कर्नल के प्रोग्रामिंग में ही इसके जो मॉड्यूल की इंस्ट्रक्शंस हैं वो डाल दी गई हैं, तो उसको आप डिसेबल नहीं कर पाएंगे।
और ये जो आप ये जो बता रहे थे ना सर कर्नल पैरामीटर्स का, तो लेट्स से कि कुछ पैरामीटर्स मतलब ऑब्वियसली आपने पैरामीटर को अपडेट किया था, जैसे कि ठीक है, जस्ट फॉर द आर्गुमेंट सेक मैं कह रहा हूँ कि अभी एक मशीन है, हमारी मशीन है, मशीन में काफ़ी सारे सर्विसेज चल रहे हैं।
जी,
तो अगर कोई पैरामीटर को चेंज करता है तो वो रन टाइम में सारे सर्विसेज को अफेक्ट होगा?
वो डिपेंड करता है कि ये मॉड्यूल काम क्या कर रहा है और इसके जो पैरामीटर की वैल्यू आपने जो चेंज की है वो कितनी चेंज की है, उससे
हम्म,
उसके बिहेवियर में चेंज आएगा। जैसे कि स्वैपिनेस पैरामीटर अगर मैंने चेंज कर दिया, तो हो सकता है कि रैम और स्वैप से रिलेटेड इश्यूज हमें देखने को मिलें। तो प्रोडक्शन मशीन पे कभी ऐसा नहीं करना चाहिए।
नहीं करेंगे।
ठीक है। आप हमेशा टेस्ट एनवायरनमेंट में पहले टेस्ट करेंगे, उसको 2-4 बार वेरीफाई करेंगे और उसके बाद ही उसे आप इम्प्लीमेंट करेंगे। ओके। ओके, लंबा सेशन हो गया, मैं सोच रहा था आधे घंटे 45 मिनट में ख़त्म हो जाएगा, काफ़ी सारी चीज़ें थी। चलिए, कोई डाउट है तो बताइए। कुछ पूछना है किसी को? अभी हम नेक्स्ट सेशन में क्या कवर करेंगे? कर्नल का एक और कुछ बचा हुआ था, केडम बचा हुआ है। नेक्स्ट सेशन में केडम कवर करते हैं, देन वी विल स्टार्ट विद क्रोन टैब। ओके, चलिए,
सर
कुछ डाउट?
मैं हाँ, एक और चीज़ ये थी सर कि लाइनेज में कोई मैनुअल होती है क्या सर? मतलब ये पैरामीटर्स के रिलेटेड कि ये पैरामीटर की क्या मीनिंग होता है, ये पैरामीटर का क्या मीनिंग होता है? ऐसा कुछ
मैनुअल
होता है?
एज ऑफ मतलब इसमें आपको CLI पे नहीं मिलेगा, आपको फिर उसे जो है ना उनके, जैसे कि रेड हैट है तो उसके पोर्टल पे जाके आपको मिल जाएगा।
पोर्टल पे जाके मिल
हाँ,
जाएगा।
जैसे कि मॉड्यूल किसने रिलीज़ किया, उसका ऑनर कौन है, उसका लाइसेंस किसके पास है, तो उसके वेबसाइट पे जाके आपको मिल जाएगा।
ओके,
क्योंकि ज़रूरी नहीं है कि सारे मॉड्यूल्स लोकली अवेलेबल हों, या मॉड्यूल्स का मैनुअल आपको वहाँ देखने को मिलेगा भी नहीं आपकी मशीन के अंदर। और पैरामीटर कितने चेंज करने पे कैसे बिहेवियर में चेंज आएगा, ये भी आपको
जी,
चेक करके ही पता करके ही इम्प्लीमेंट करना है।
इम्प्लीमेंट करना है।
जैसे कि VM स्वैपीनेस जो पैरामीटर है उसकी वैल्यू मैं अपने केस में चेंज करता हूँ तो शायद मशीन अलग तरीके से बिहेव करे, आपके में शायद उसका बिहेवियर अलग हो जाए। वो डिपेंड करता है कि उसका मतलब मैन्युफैक्चरर कौन है, क्या रिसोर्सेज हैं, कितनी कैपेसिटी है, किस तरीके से यूज़ हो रहा है, वो बहुत सारी चीज़ों पे डिपेंड करता है। तो ज़रूरी नहीं है जो पैरामीटर की वैल्यू मेरे केस में हो उसी का वो सेम इफेक्ट आपके केस में देखने को मिले। हाँ, जो उसका बिहेवियर रहेगा वो रहेगा एक जैसा ही, लेकिन एग्जैक्ट सिमिलर हो ये ज़रूरी नहीं है।
ओके,
ठीक है,
थैंक यू सर।
लेकिन हम डिफ़ॉल्ट के साथ ही जाते हैं। मॉड्यूल्स की हेल्प से हम फंक्शनैलिटी ऐड कर सकते हैं, फीचर ऐड कर सकते हैं, बिहेवियर में चेंजेस कर सकते हैं, सर्टेन फीचर्स को इनेबल या डिसेबल कर सकते हैं।
इस्तेमाल कर सकते हैं।
लेकिन जब तक ज़रूरी ना हो तब तक हम नहीं करते हैं। जब तक हमें एक्सप्लिसिटली उसको डिफाइन करके यूज़ करने की ज़रूरत ना हो तब तक नहीं करते हैं।
आपने एक वो कहा था ये, हाँ, मॉड्यूल मॉड्यूल लोड करने का जो आप बता रहे थे ना सर कि मतलब अगर आप जैसे कि मॉड प्रोब है, ये तो पैरामीटर मतलब परमानेंटली इस चीज़ को वो नहीं करता है। तो परमानेंटली करने के लिए आपने कहा था कि ईटीसी में एक वो फ़ाइल बनानी है मॉड्यूल करके, और एक दूसरी ईटीसी मॉड्यूल लोड और डॉट डी करके फ़ाइल में।
जी,
तो वहाँ पे एक आपने एक फ़ाइल कुछ बनाई थी कि 99 हाइफ़न कस्टमर
वो
डॉट कॉन्फ,
किसी
आई
भी
नो
नाम
कि
से,
वो
किसी भी नाम से
किसी
बना
भी नाम
सकते
से,
हैं,
हाँ।
किसी भी नाम से बना
बट
सकते
लेकिन लेकिन बट मैंने देखा है कई लोग जो है वो नंबर से फ़ाइल बनाते हैं। आई नो कि वो कुछ ऐसा स्टैंडर्ड तो नहीं है, बट लेकिन उसका कोई वो ऑर्डर रहता है क्या सर? प्रियोरिटी वगैरह कुछ भी ऐसा?
हैं। नंबर से इसलिए बनाते हैं, मेरे ख्याल से वो डेट के हिसाब से बनाते हैं। जैसे आज मैंने 29 तारीख को चेंज किया या 29 तारीख को फाइल बनाई, तो मैं 29 से स्टार्ट कर दूंगा ताकि मुझे ध्यान रहे कि ये फाइल मैंने 29 तारीख को बनाई थी। इसलिए करते हैं ज़्यादातर
हुँ,
केसेस में। या बैकअप लेंगे तो बैकअप के बाद वहाँ डेट की जगह नंबर डाल देंगे। तो आप किसी भी नाम से बना सकते हैं। जनरली क्या है, हम कभी भी जो डिफ़ॉल्ट कॉन्फ़िगरेशन फाइल्स हैं उनमें चेंजेस ना करें। ऐसा करने से अवॉइड करने के लिए हम डॉट डी नाम से डायरेक्टरी होती है, उसके अंदर किसी भी नाम
हाँ,
से फाइल बना सकते हैं सेम एक्सटेंशन की, तो वो सेम तरीके से बिहेव करती है। क्योंकि पहले क्या हुआ करता था, हमें डायरेक्टली कौन फाइल में चेंज करना होता था जो एक ही डिफ़ॉल्ट फाइल है, उसकी वजह
डिफ़ॉल्ट
से
रहता
हम
है।
किसी, अगर कोई एंट्री हमने गलत कर दिया, किसी दूसरी एंट्री को हटा दिया, तो फाइल में चेंजेस आने की वजह से सर्विस इम्पैक्ट हो जाती थी। और अगर हमने बैकअप नहीं लिया हुआ तो प्रॉब्लम क्रिएट हो जाती थी। तो बेहतर ये है कि आप सेपरेट फाइल बनाएं और उसमें एंट्री करें, ताकि आपकी जो डिफ़ॉल्ट फाइल है वो इंटैक्ट रहे।
हुँ,
ठीक है। जबकि ईजी हमें वो लगता है सिंगल फाइल में चेंज करना, लेकिन जैसे 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 आप सीखते हुए आगे चलते हैं, एक्सपीरियंस होता है, तो बेटर ये है कि आप डिफरेंट फाइल बना लें, उस मॉड्यूल डॉट डी या जिस भी नाम की जो सर्विस है उसके नाम से, डी डॉट डी के नाम से आपको डायरेक्टरी मिलेगी, उसमें फाइल बना लो।
और डायरेक्ट फाइल में करने से सर वो ट्रैक करना मुश्किल हो जाएगा बाद में, कि
मुश्किल भी
किसने
होता है,
क्या-क्या
करप्ट
कर
होने का चांस भी रहता है, कई
क्या
बार
कॉन्टेक्स्ट
मल्टीपल
में कर
यूजर्स होते हैं जो सेम टास्क कर रहे होते हैं। मैंने एंट्री ऊपर कर दी, आपने नीचे कर दी, मुझे आपकी नहीं दिख रही, आपको मुझे मेरी नहीं दिख रही, तो उससे प्रॉब्लम होती है फिर।
ठीक,
ठीक है, चलिए गाइस,
थैंक
ओके,
यू।
ठीक है, थैंक यू, आई विल सी यू ऑन सैटरडे, गुड नाइट।